back. So we've looked at how do we start the balancing process of balancing chemical equations. Today we're going to look at how do you physically make both sides, the product and the reactants and the products have the same number. So to balance a reaction, we add coefficients in front of the molecules until the atom counts become equal on both sides. So in our example here, remember the coefficient is the number in front of the molecule. It's the number of molecules, right? And that 2 or that number affects all of the atoms in that molecule. Okay. As opposed to the subscript, we never, ever, ever change the subscript, right? If we change the subscript, we're changing the molecule. We don't want to do that. Okay. We add coefficients because formulas cannot be changed. Okay. You can add more molecules. You cannot change the molecule itself. Coefficients are always whole numbers. So you'll notice this is a 2 and not a 2.1 or a 1/2 or any of that kind of thing. Okay. Here are some tips and tricks to balancing, some things that you can think about. First off, try balancing in this order. Do metals first, then non-metals, then hydrogen, then oxygen. Write out an inventory list similar to what this person has done over here. So they have their equation. They wrote out what are all of the different atoms that are being used, and then how many of each are there. Make adjustments to other atom impacted by coefficient changes. So this 5 changed that O2 into 10 instead of 2 oxygens. Okay. If everything balances except for the oxygens, double all the coefficients and try again. So if the oxygens here hadn't balanced, we could double all of our coefficients. So our 5 would become 10 and our 4 would become 8 and our 3 would become 6, and then try to balance after that. Okay. And then a shortcut, if you have a polyatomic ion like phosphate or carbate or something like that, carbonate, that appears on both sides of the equation, you can balance them as a group. And in my example, I show you that. Okay. So here's what we're doing. We're going to balance the reaction. We're always going to start by counting the number of atoms on each side of the arrow. So if you notice here, I have 3 hydrogens, and then this is that quick trick, right? I have a PO4 on this side and I have a PO4 on this side. So I can keep the PO4 together. I don't have to separate them. Okay. So I have 1 PO4 here and I have 1 PO4 here. Okay. I have a potassium here. So I have 1 potassium. I have a hydroxide. Okay. Again, this is a polyatomic, so I can keep them together because they're the same on both sides. Okay. And then on the other side, I did the same thing. So if we look, we can tell right straight away that they are not balanced. So the first thing we want to do is we want to look at our metals. And the metal in this particular equation is the potassium. And so the K, I have a 3 on this side and I have a 1 on this side. So what I need to do is I need to figure out what number can I put in this blank, right, to get my K to be a 3. So in order to do that, I would need to put a 3 there, right? Now I need to go back and I need to change the counts for the atoms that are affected. So here now I have 3 Ks and I have 3 OHs. So I can change those. It's still not balanced because my OHs aren't balanced and my H's aren't balanced. Okay. So the next one would be to do your non non-metals. And in this case, my non-metal is the OH. Okay. And so if I look here, I have 3 OHs here and I only have 1 over here. So what can I do? What can I put in that blank in order to get 3 OHs? Well, again, I can put a 3 in there. And so now I need to recount again. So now I have 3 hydrogens and 3 hydroxides. Okay. So if I look, now I'm balanced. So I haven't filled in all of my blanks, but I'm balanced, and that's okay. The last thing that we want to do, and we only do this in high school, and you don't do it out in the real world, but we're going to fill in those empty blanks with X's, okay? And that's to say I'm not putting anything in that blank, okay? So if we look at this again, I started with counting both sides, how many H's, how many PO4s, how many OH's, and how many K's. I then looked at my metal and I said, okay, how many potassiums do I have and are they balanced? Well, they're not balanced. This side has 1, this side has 3. How do I get this side to have 1? I put a 3 in the blank. Then I have to recount my atoms, right? So I now have 3 Ks and I have 3 OHs. Okay. And then now my OHs don't match. So I need to go with another 3. And that affects my hydrogens and my hydroxides. And now if I look, that's balanced. And then in terms of this class, the last thing you're going to do is put X's in the blanks that have nothing in it, okay, to show that there's nothing in that blank. Okay, so if you want more examples, please feel free to watch the balancing examples video where I work out more examples. Good luck.